Okay, now we are on our fourth video, and this video is about converting mass to particles and particles to mass. Okay, so we will use again the diagram. This diagram, analyze. So our target is to convert this gram into an atom or atoms, molecules, or formula units. Therefore, we have two processes that involve here. You need to undergo the molar mass, or you need to use the molar mass here, conversion. And you need to use here the Avogadro number, which means to say you will be using two conversion factors. Okay, so let me uh, give you what is meant specifically by that one. So when we say 1 mole of a substance is equal to grams, what is that of a substance? That's the molar mass. Okay, that's one. Then another representation is 1 mole of a substance is equal to the Avogadro's number 6.02 times 10 to the 23rd particle. Okay, so please take note that these two will be used only if the problem is about mass to particles or particles to mass. Okay, now uh, let's have a sample problem. Again, in this discussion, I have only 3 or 4 sample problems. Please have with you your calculator and your periodic table. Okay, so let's have the first problem. How many atoms of potassium are present in 78.4 grams of potassium? So take a look at the problem. It is mass to atoms. Therefore, you need those two molar conversions. So, first conversion is 1 mole of potassium is equal to, let's take a look at the atomic mass of potassium, 39.098. So, convert that, we have 39.10 grams there. Then another conversion that I've said, 1 mole of potassium is equal to 6.02 times 10 to the 23rd. This is an element, therefore we use atom. Okay? Then we place this in a T form, in the T form, or you can simply use multiplication and the ratio. I will use multiplication. So given in the problem is 78.4 grams potassium. I will multiply this grams. This is in grams. So I'm thinking of what will I place? What should be placed rather in the denominator? What should be placed so that I can cancel that gram? Therefore, you will put in the denominator 39.10 grams of potassium, 1 mole of potassium. Okay, so we cancel out the grams because it's equal to 1. Is that clear? Next, moving on, it is still not yet, or it's not yet complete, or it's not yet finished rather, because take a look at the unit. Left, it is in moles. But the question is, it should be in atoms. Okay? So we have times, we can add additional okay, conversion. So times 1 mole of Kelvin, 6 point, Kelvin, sorry, of Potassium, 6.02 times 10 to the 23rd atoms of potassium. We cancel out the mole. So let's use the calculator. Please take note that this is in the denominator. Therefore, you're going to divide this. This is in numerator. Therefore, you're going to multiply 78, 78.4 times 1 times 6.02 exponent 23, they divided by 39.10. The answer is 1.21. So we have here 1.21 times 10 to the 24th atom of potassium. Okay? You pause this video and give it a try and review the process as well. Okay. Now, let's proceed to the next part. Let's proceed to the next part. We have here, find the mass of 2.1 times 10 to the 24th molecules of sodium bicarbonate. We need to get the molar mass of NaHCO3. Okay, are you ready? So, 1 mole of NaHCO3 is equal to how many grams of NaHCO3? Okay, so now let's have sodium Na. I will do the shortcut here. There is only one atom. So sodium is 22.99 times 22.99. Then we have hydrogen, one atom only, 1.01. Then we have carbon, that's one atom, 12.01 grams. And then oxygen, it's three. It's having three atoms there in the formula, then times 16. Okay, add it up, please, and you will get 84.01 grams. That's the molar mass of NaHCO3. And we're not yet done. 1 mole, we need to have another conversion. CO3 is equal to 6.02 times 10 to the 23rd a molecule of NaHCO3. So you have two conversion factors to be used here. We write the given, again, molecule to be converted to grams or mass. So we have 2.1 times 10 to the 24th molecule, not mole, of NaHCO3. Okay, that's in molecules. So I have here molecules. So I will place 6.02 times 10 to the 23rd molecules. Allow me to do the shortcut, NaHCO3. Okay, next, that's 1 mole of NaHCO3. We cancel the molecules. Then we have 1 mole of NaHCO3 is equivalent to 84.01 grams of NaHCO3. Get that? Please mimic that. Do that on your own. Now, we will do the calculation. This is multiplication, and then you're going to divide it because this is division to 6.02. So 2.1 exponent 24 times 84.01, okay, divided by 6.02 exponent 23. Okay, what did you get there? Pause the video first. Try to answer it in your own before you provide to me the answer. Okay, so using that, we have 2.01, right? Okay, we have, I hope, it's 293.06 grams of NaHCO3. Okay, would you like to review times 84.01 divide 6.02 exponent 23 again? So that's it. I have with me 293.06 grams of sodium carbon. Okay, can you see the difference of the previous video tutorials that I had with this one? Okay, now let's have one last sample exercise. One last sample exercise. Let me clear that. Here we have a mass in the grams. What is the mass in grams of 1.20 times 10 to the 24 molecules of glucose, C6H12O6. Okay, so I have with me molecules of glucose, molecules to mass. Therefore, I need to have the conversion factor of molar mass rather, of C6H12O6. So for shortcut purposes, 6 times 12.01 plus, you have 12 times 1.01 plus 6 times 16.00. Okay, let's have 6 times 12, sorry, 6 times 12 is equal to 72, or 6 times 12.01 is equal to 72.06, okay, plus we have 2.02, 12.012 rather, 12.012, and is equal to plus 6 times 16. I hope you have 180.18. This is this is on the spot. Now, if you have any problem with my calculation here, please feel free to correct Miss Michelle. Okay? I will review it again. 6, so we have 6 times 12.01 plus 12 times 1.01 is 12.12 plus, okay, 6 times 17. Let's see. Oops, I have 186.18. I have 186.18. My gosh, I have to review it again. Plus, plus 6 times 1 moment, please. 180.18. Am I right? Yeah, 180.18. Hopefully. Now, let's just assume that that's make corrections later. Now we have 120.24. 120 times 10 to the 24. So I will write 1.20 times 10 to the 24. Okay, so molecules times 1 mole of C6H12O6. You have to label because in stoichiometry it can be converting one substance to another substance, C6H12O6. So we have molecule 6.02 times 10 to the 23rd molecule of C6H12O6. times 1 mole of C6H12O6 and 180.18 grams of C6H12O6. Okay, let's work with the unit to be cancelled. Molecule divided by molecule is equal to 1. Mole divided by mole is equal to 1. So we are left with grams, which is addressing the unit is addressing our problem. So 1.20 exponent 24, press that please in your calculator, times 180.18, okay, divided by 6.02 exponent 23. Okay, so how many in grams, or what is the mass in grams of 1.20 times 10 to the 24 molecules? And that's in 359.16 grams of C6H12O6. Okay, so 9G, that is the correct answer. If you want to be clarified and make some corrections here, just tell me, as long as um, you have valid reason for that, or maybe because it's out of my carelessness. Okay? So I hope you got it right. This is converting mass to particle, particle to mass. Okay?